Okay, so we are adding and subtracting rational numbers, which are positive and negative fractions. And when we add rational numbers, we need a common denominator. And we figured that 4 goes into 12 3 times, so we know 12 is our common denominator. So the next step is I'm going to write out both fractions with denominators of 12. Notice I didn't touch the numerators yet. Okay, I haven't touched them yet. So, did the denominator change in the first fraction? Josh, did the denominator change in the first fraction? Did the denominator change in the first fraction? No. So does the numerator change? No. Okay, so I'm just going to keep the 7 there. Does everyone understand that? The denominator doesn't change, the numerator doesn't change. Okay? In the second fraction, did the denominator change?
Yes.
Yes. And it's always multiplicative. So what do I have to multiply 4 by to get 12? 3. What if I didn't know that? How could I use my calculator to figure it out? 12 divided by 4. So if you're not, the times table champion of the class, then you have to remember, I could do 12 divided by 12 divided by 4, and that would give me the 3 that's right here. Okay? So to make an equivalent fraction, whatever I did to the bottom, I also have to do that to the top. So what is 3 times 3? 9. So when I change the denominator, I have to change the numerator by the same multiple. Does that make sense to everybody? So what I want you to do is get your calculator out, and I want you to show me decimal-wise that 3/4 is the same as 9/12. So you know in your heart you haven't changed anything, you've just written it differently. So if you do 3 divided by 4 on your calculator, what do you get? Your calculator and do 3 divided by 4, see what you get. Yep, 0.75. Now I want you to do 9 divided by 12 on your calculator and see what you get. 0.75. So that's a way to check. Once you've got your common denominator step, that's a good way to check for you if you've adjusted the numerator properly. Okay? Everyone see that that's a good way to check? Make sure you got the right number up here. Okay, so now instead of 12ths and 4ths, which are like apples and oranges, you've got 12ths and 12ths. So if I have 7 12ths and someone gives me 9 more 12ths, how many 12ths do I have altogether? I've got 7 12ths, you give me 9 12ths, how many 12ths do I have? 16. 16 12ths. Okay, or you can think of it as you keep the denominator the same, the common denominator the same, and you add the numerators. Okay? So it's all about the 12ths. I've got 12ths, I'm getting more 12ths, so now I've got 16 12ths. But I want my answer in lowest terms. So, is there a number that goes into 16 and 12? 4. 4. So 16 divided by 4 is 4. 12 divided by 4 is 3. And again, to make sure you reduce properly, you can do 16 divided by 12 and make sure you get the same as 4 divided by 3. So 7 12ths and 3/4 is 4/3. Okay? 7 12ths and 3/4 is 4/3. Or if you like a mixed number, what's another way to write 4/3?
1 and 1/3.
Yeah. So a whole is 3. So 3 goes into 4 once with 1 left over. 1 and 1/3. Nice. In grade 9 and going forwards, usually they like you to end with an improper fraction in lowest terms, unless it's a word problem, and then often it makes more sense to answer with a mixed number. Okay? All right. So that's the idea. Now we're just going to look at finding a common denominator. And the key word is here, multiply. So we never find a common denominator by adding, okay? It's always multiplicative, multiply related. All right, so all I want you to do is look at the denominators and figure out the common denominator here. Don't worry about the numerators for now. We just want to know what the common denominator is. So we've got fourths and eighths. Does anyone think they know what the common denominator would be? Jake. Eighths. So again, the first test is, can I do the bigger number divided by the smaller number? 8 divided by 4, do I get a whole number? Yes, 2, so I can use 8 as my common denominator. Okay, I'm just going to write 8 in here, because it says common denominator. 3 and 4. Common denominator. Yeah. 12. Good. So 3 times 4, because 3 doesn't go into 4 evenly. 12 would be my common denominator. 2 and 11. 2 and 11 would be my common denominator. 22. So you multiply them together. Awesome. 5 and 4. Common denominator. Oh, 20. Good. 1 and 5, 6, and 2 and 4 fifths. Yeah. 30. How did you get that?
I just said 6 times.
Okay, so did we have to change to an improper fraction in order to figure out the common denominator? No. Okay. Might we want to change to improper fractions to add or subtract? Yes, but we know that this one's going to be 6 and this one's going to be fifths. So I'll highlight those. And 5 times 6 is 30. Awesome. All right, this one we've got 3 fractions. We need 3 colors here. We've got a half, 2 and 2/3, and 7/8. Anyone think they've got a common denominator for 3 cadence? 24. So how did you get that? Because you didn't multiply all 3 together.
Well, I just had 3 times 8 and I saw that it was even.
Nice. So she did 3 times 8, because 3 is odd and 8 is even, and it's bigger than 2. And she got 24, and then she checked to see, is 24 divided by 2, does 2 go in? Yes, it's a whole number, so 24 can be her common denominator. If you did 2 times 3 times 8, you'd get 48, which is also a common denominator. It's not the smallest. All that would mean, though, is that you'd have more reducing to do at the end, which is fine, okay? So if you're stuck, you can always multiply the denominators together and you will get a common denominator. It may not be the smallest, but you'll get one, and it will work, okay? All right. So now that we kind of got our brain wrapped around common denominators, we're going to do this one because of the negative signs here. This is important. All right, so change each mixed number to an improper fraction. That was something some of you struggled with on the EDSB quiz yesterday. Some of you just didn't quite have it yet. So someone that understands it, or maybe after the first lesson today understands it now, hand up and explain to me how to get 3 4/5 of an improper fraction. What the thinking is. Yeah.
Times the whole number by the denominator and then add 4.
Okay, so the trick is multiply those two and add the numerator. So 15, that's 19 fifths. Okay. Or the thinking is there's 3 holes, and each hole is made up of 5 parts, right? So that's 15 parts. So 3 holes is 15 parts. But then you've got 4 more parts, and that gives you the 19. And what are our parts? Fifths. Okay? All right, these are the ones I'm going to star, because these are the ones, especially when you're using the little multiply and add tricks, that frustrate people or So we're gonna do an example here. If you dive below the water, so say you're diving -6.5 feet. So here you are, and here's the water, and you dive 6.5 feet down, okay? What's that gonna be as an improper fraction? -6.5 feet, so 6.5 feet underwater, -6.5 feet. Anyone think they know? Jacob?
Is it negative 5 over 2?
Okay, you think what?
Negative 5 over 2.
-5/2, and how did you get that?
Negative 6 times 2. Oh, wait. Oh, no, I'm thinking about the question, sorry. Oh,
Okay, that's okay.
It's negative 11.
You think -11/2. Okay, so do that on your calculator. What do you get? Or in your mind, -5.5? Do you see that? What's wrong with that though? I went -6.5 underwater. Does everyone see that? So I went more than 6 feet underwater, not less than 6 feet underwater. So when you're doing the trick, you ignore the negative sign. Okay? We know we're going down, so we know it's negative. Then I just want to change 6.5 to an improper fraction. So that's going to give me 2 times 6 is 12, plus 1 is 13 halves, and that's really what I did. Does everyone see that? A very common mistake in grade 9, okay? Very common. So you have to remember and ask yourself, and the other way to ask yourself is to check this and make sure they're the same. Okay? All right, so thinking of that now, so if I do questions like this, I just ignore the negative for now, and I put it down there. I just know my number is going to be negative, but I'm thinking if I want to change 2 3/4 to an improper fraction. I know the answer is negative, so I'm not taking the negative into account right now. I'm just saying I've got a negative number. Now that negative number is going to be whatever 2 3/4 is as an improper fraction. Anyone know what 2 3/4 is? Yeah? 11/4. So 4 times 2 is 8, plus 3 is 11, or 2 wholes is 8, plus 3 more is 11. Okay? All right, lovely. Does someone think they got this one? Yes?
Would it be -17/3?
It would be. Very good. So we know it's negative, and then how did you get to the 17?
I added 5, no, I times 5 by 3, and then added 2.
Very good. How many people got -17/3? How many people got -13/3? Nobody? Okay, so nobody made that mistake over there. This is right. Awesome. We'll be practicing it more today, so we'll keep explaining it or have people explain it to us. Okay, so when adding and subtracting rational numbers, you need a common denominator. You need one first. And then you add or subtract the numerators. The denominator doesn't change. That's another thing people forget. Okay, so we're going to add or subtract here. So I've got 11/12. I'm taking away 5/12. I'm lucky on this question because I'm already got the same denominator. I've already got a common denominator. So 11/12 subtract 5/12. What do you think? How many 12s would I have? 6 12s. Good. Now is that in lowest terms?
Whatever, yeah.
Good. So 6 goes into both. So I can reduce that to a half. Lovely. And then again on the second one here, I'm lucky again. I've got 11ths and 11ths, which is lovely. So I don't have to get a common denominator. I already have one. So 3 11ths, and then I get 5 11ths. How many 11ths do I have altogether? 8, good. 8 11ths. Now, another common mistake that I see grade 9s making is they put 8 over 22. Can someone tell me what the misunderstanding is if they put 8 over 22?
Yeah, they're adding one.
They add the bottoms, right? But we don't. We keep the common denominator and add or subtract the numerators. Okay, so denominator stays the same. If you're a little shaky on that, write yourself a note. And you can think of it as, I'm adding 11s together. They're not all of a sudden going to change. I've got 3 11s, someone gives me 5 11s, I've still got 11s. Okay, they don't change into something else. Okay, now we've got 2 different denominators. One's 4 and one's 8. So this is the first time we have to think about getting a common denominator before we add or subtract, in this case add. So does someone know what the common denominator would be? Yeah, 8, because 4 goes into 8. So you try your calculator, 8 divided by 4, and it goes in evenly, so they're going to both be out of 8. And then you're going to ask yourself, did the denominator of the first one change? Did the denominator change? Yes. So the numerator has to change as well. Okay? So what do I have to multiply 4 by to get 8?
2.
2. And if I didn't know that, I'd do 8 divided by 4. Okay? I didn't know that, I'd do 8 divided by 4. So that means I have to multiply the top number by 2 as well, which gives me 6. Can everyone get a 6 there? Okay, so 3 times 2 is 6. Then I look at my second fraction. Did the denominator change? No, so the numerator doesn't change either. Okay? Now I've got 8, so I've got 6 8s. Someone gives me 3 more 8s, so altogether I have 9 8s. Is that reduced? Yes. If you really have the urge to write it as a mixed number, you can, but you don't have to. So it's going to be 1 whole with 1 8 left over. Okay? This is unnecessary, but if you like it better that way, okay. All right. 4/5 minus 1/3. So I'm going to. All right, who figured out a common denominator for 5 and 3? Alexa. 15. 15, nice. How many people got 15 for their common denominator? Lovely. Okay, so did the denominator change? Yes. Okay, and it's always going to change multiplicatively. So if I don't know what I had to multiply 5 by to get 15, I need to do 15 divided by 5. And whatever I did to the bottom, I now do to the top. So 4 times 3 is 12. If I wanted to check and make sure I was right, I would do 4 divided by 5. That would give me 0.8. And check that 12 divided by 15 also gives me 0.8. And then I can be sure. Okay? Over here, I had to multiply 3 by 5 to get 15, so I have to multiply 1 by 5. You saw it. Very good. Okay, so that should be your second step. 12 15ths minus 5 15ths. So if I've got 12 15ths and I take away 5 15ths, how many 15ths do I have? 7. And then I would check if that reduces. But 7 doesn't go into 15, and there's no smaller number that goes into both, so I'm done. Okay, 2 3/4 plus 2/3. So I know there's different ways to do this, but the most common way you're going to use going forward is to change any mixed numbers to improper fractions as your first step. Okay? That's going to be the most efficient way going forward. Okay? So how do I change 2 3/4, anyone, to an improper fraction? From?
Multiply 2 and 4 and then add 3.
Good. So 8 plus 3 is 11. Did you say wait, what? You got that? Okay. So once you've changed it, now you're gonna look at your denominators and figure out what the common denominator is. So if my denominators are 4 and 3, how can I get my, William, off your phone? How can you get the common denominator? Yep, multiply. Multiply them by each other, nice. Okay, I'm gonna pause. Okay, what number did you get on in the numerator once you change to 12? So that's 33. So 4 times 3, 11 times 3, awesome.
And the other one?
Yeah,
Oh, 8.
8. 3 times 4, 2 times 4. How many people got the numerators, the tops correct? Yes, anyone have a question about the tops? Okay, so 33 twelfths, and then 8 more twelfths is 41 twelfths. And that can't be reduced. You could write it as a mixed number if you want to, so 12, 24, 36. So 3 wholes with 5 left over. This is OR. Okay, next one. Okay. Change that number. So who thinks they've got this number changed to an improper fraction? Alexa.
Negative 13.
Negative 13 fifths?
Yeah.
Nice. Everybody get negative 13 fifths? Anyone need an explanation of how to get that? Okay, good. So we've got 2 different denominators here. So we need a common denominator. What's that going to be? Yeah, 20. And how did you get that? 5 times 4. Awesome. So you can always multiply to get a common denominator. You can always multiply. So here I had to multiply 5 by 4. So I also have to multiply negative 13 times 4. And that's going to give me negative 52. Notice how the negative was out front here, but I like to keep it negative with my top number. Since I have the choice of putting it with the top out front or at the bottom, I always like to keep it with the top number when I'm computing things. Okay, so negative 52 twentieths. And then here I had to multiply by 5, so I have to multiply 1 by 5. Does that make sense? All right, so then I owe negative 52 20ths. Someone gives me 5, so now I only owe.
She's only got one sheet here. She doesn't have the next page.
Yikers. Oh, okay. Okay, I owe 52, someone gives me 5, so now I only owe how many? Good. Negative 47 20ths, can that be reduced? What goes into 47? I think it's prime. Nope. 47 is prime, so that's the best I can do unless I want to change to a mixed number. All right. Okay, so first step here is to change these mixed numbers into improper fractions. Okay, that's going to be your first step. You can go. Change those into improper fractions. Five times 1 is 5 plus 1 is 6 fifths. Minus 2.5 can be written as? Yep. 5 halves. Okay, so then I'm gonna look at my three different denominators and get a common denominator. So anyone get to that? Do you know what the common denominator is? Brock? 20, good. Did anyone get 40? They'll still work, you'll just have more reducing to do. Okay. All right, so the denominator changed in all of them. So the numerators have to change in all of them, okay? Remember the dividing trick will always tell you whether you adjusted them properly. So I had to multiply 5 by 4. So 6 times 4 is 24. I had to multiply 4 by 5. So I have to multiply the top by 5. Here I had to multiply 2 by 10. So I have to multiply the top by 10. And I get 50. So I had to multiply 2 by 10 to get 20, so I have to multiply 5 by 10 to get 50. Whatever you do to the bottom, you do to the top, make the bottom change. Okay? Alright, so now you can think of this as 24 plus 15 minus 50 all over 20. They're all 20ths. You don't have to write this stuff if you don't want to, but you can think of it like that. So you just have to add, subtract the numerators over the common denominator. The denominator stays the same, really important. Common mistake is to add, subtract denominators. So that's going to be 39 minus 50. So we're going to be negative 11
Yeah.
20ths. Does that reduce? No. You're done. Okay, our last question. For practice. Okay, so when I see the negative out front, but I'm working with the number, so I'm adding, subtracting, I'm going to rewrite it with the negatives in the numerator. And I'm subtracting a third. So I've got negative 7/8, subtract a third. So now I'm looking for at the denominators. They're different. So I'm going to need a common denominator. I would check, does 3 go into 8? No. So then I resort to multiplying. 8 times 3 is 24. The denominators change, which means the numerators need to change. Okay? So 8 times 3, negative 7 times 3. Use your calculator for that if you're not good with your times tables. Negative 7 times 3. Negative 21. Good. 24 divided by 3 is 8. So 3 times 8. 1 times 8. Which I can think of as negative 21 subtract 8, 24ths. The denominator stays the same. I have to figure out what negative 21 minus 8 is. So I'm at negative 21 and I'm subtracting 8, so I'm still going that way. Negative 29 24ths, and does that reduce? No, 29 is prime again. Okay? All right, awesome.